Well, welcome to video 2 for this test. We're going to start out. We're going to mention this, and we're going to really talk about this a lot later. One of our chapters in Chemistry 116 is nuclear chemistry. It's really interesting. So when we get to this, we're going to talk about radiation, but we need to talk about it just briefly. Once again, a little bit of overlap. Some of the things I mentioned in Chemistry 115 before we get to this class right here. 3 types of radiation: alpha, beta, and gamma. Now, what's key right now when we get to nuclear chemistry, we'll talk about what causes alpha radiation, what causes beta, what causes gamma, what happens in terms of the molecules, what happens in terms of the protons and the neutrons. But what we need to know right now is how we can detect this. Alpha, what stops alpha radiation? So if I've got a Geiger counter and I'm looking at it and I'm measuring alpha radiation, and then I'm also, and there's other ways to measure alpha radiation. I'm looking at this. So what stops alpha radiation? A sheet of paper stops alpha radiation. Isn't that cool? Just a single sheet of paper actually stops that. Beta radiation, about a book of 100 pages actually stops beta radiation. And then gamma radiation, this is the radiation that you have when you go to the hospital and you get an x-ray, even in the dentist office when they give you that brief little 2-second shot at your tooth. That's why we have to have an inch of lead or concrete. So we'll actually put lead in there. We'll stop that gamma radiation, and when you get an x-ray in a doctor's office, we'll actually use lead. Probably won't have a concrete vest that you put on. That would be a little not so fashionable. But usually use lead. And so what's wrong with this picture? We're also talking about how lead's a problem. So isn't it kind of ironic that we talk about lead being a problem? And the reason is because once again, what are we talking about? Instability. We're talking about ions, isotopes. We're talking about instability. And anytime we have something that's unstable, then we have an issue in chemistry. Because remember, from the beginning of the very course, everything wants to be stable. So these are forms of instability. But let's talk about radiation for a second. When cell phones first came out, it was a big deal. People said, well, we're going to listen to these cell phones so much, and there's a certain amount of radiation. As a matter of fact, our bodies give off a certain amount of radiation. We give off alpha radiation, but these phones give off alpha radiation. People said, "Wow, we're going to be getting brain tumors from the radiation from the cell phones." Well, what happened was it was alpha radiation. So some people picked up on that, and they said, "Hey, for $9.95." We can send you a radiation, we can stop your phone from radiation. Well, it was kind of cool because back then the phones weren't even as thin and weren't as streamlined as they are right now. But what happened was these people made a lot of money doing this, so they sent in their $9 or their $20, whatever they were asking, and they got back this little kit, and they gave them a piece of cardboard, and then they said, trace your phone and put this in on the back side of your phone, okay? So you can actually take off the back of your phone, lay this cardboard up in the back of the deal, and no more alpha radiation. Why? Because it's kind of cool, because then that part of the phone that had the cardboard on there was against your ear, and so that stopped the alpha radiation. So once again, wasn't false advertisement, it actually worked, but now all your phones actually have a filter in the back of your phones by law to stop alpha radiation. Isn't that cool? So once again, a pretty simple deal. When we hear the word radiation, here's probably the biggest point I want to make at this point in the discussion, is that there's different types of radiation. So alpha is pretty minor in that a sheet of paper can stop it. Beta, a book of paper, and gamma is a lot more serious, an inch of lead or concrete. So once again, 3 different types of radiation. Now, I want to come in and I want to define a salt. Okay. Now we hear the word salt. So what is a salt? Okay. Well, a salt is any ionic, once again, different number of electrons, has a positive or negative charge. A salt is an ionic compound that contains a positive ion other than hydrogen and a negative ion other than hydroxide. Okay? So what are we talking about here? Well, here we go. Let's look at this. So would it be hydrochloric acid where we have a hydrogen ion and a chlorine ion? No, it couldn't be hydrochloric acid. That's not a salt. Why? Because it has to be other than, the positive ion has to be other than hydrogen. So once you get hydrochloric acid, so that wouldn't work. So then it says also, and a negative ion other than hydroxide, so it could be NaOH, that it would have a negative OH ion. So we look at all the different ones it could be, and so sodium chlorine sodium chloride is a very famous salt. It's table salt. We'll talk about that a little bit later. But there's a lot of salt. So anything that has a plus ion and a minus ion making an ionic bond, okay, they come together and make a zero charge, all right, they complement each other, but it has to, the positive ion has to be something other than hydrogen, and the negative ion has to be something other than hydroxide. Okay, so here are some common salts, all right, so we have, we move over to this side of the board a little bit, we have sodium chloride, that's table salt, the formula NaCl, sodium chloride, we have this with naming. And then there's a couple different ways actually to write. Now some of you every once in a while, some of you will say, okay, I see a different way I can write this, or I learned this different, or I looked this up on the computer and it came out something different. Yeah, let me explain. There's a lot of different chemical compounds out there, a lot of different things, because it depends on, it's really interesting because a lot of chemical compounds can only exist for 2 seconds, and then they combine with hydrogen in the air, or they do something to react. So you will see different chemical compositions and different compounds actually labeled different ways. And so as we get into, even early in the class when we had this, we gave you the naming and we gave you a lot of things. So even then we just gave you basic, and we'll say, okay, well, this is what we give you for the formula for this particular compound, but this is what we show for the formula, because the minute it's created, it becomes this. So it's kind of interesting. So by name, sodium what? Bicarbonate is NaCO3 2. Sodium, and then here's carbonate, remember O3 is 8, so carbon 8, and then we've got bi on there meaning 2. Now, this is, when you see sodium bicarbonate, you'll actually see, the reason I give that example, probably see a little different, formula, but we'll start with this because we've got to show you how it reacts. Now, so sodium bicarbonate, that's also baking soda. Now, I might ask you on the test, I haven't made the test out yet, but you'll definitely need to know the chemical formula and then the scientific name. You may or may not need to know the common name, but it's good to know. When we talk about table salt, that's sodium chloride, NaCl. We talk about baking soda, it's sodium bicarbonate, okay, NaCO3 2. Now, then we have calcium carbonate, okay, so we're beginning to see a lot of salts here, where instead of the hydroxide ion, we're finding out that carbonate's a pretty good negative ion over here, as well as chlorine. So when we get to electronegativity, we'll begin to show you why these things develop charges like they do. So calcium carbonate, that's your Tums or Rolaids, something that you might take for an upset stomach. So you'll definitely need to know those formulas and names, and the common names. I may even ask you what is the scientific name and the scientific formula for baking soda. And you'll say, well, the scientific name is sodium bicarbonate. The formula is Na, and then in parentheses CO3, and then subscript 2. So once again, these are just some of the common salts. There's a lot more out there, but we just want you to begin to associate salts with something besides a hydrogen and a hydroxide ion. So the most common base used to neutralize sulfuric acid and hydrochloric acid. Remember sulfuric acid, H2SO4, okay, and you remember hydrochloric acid, HCl. So what do we use mostly to neutralize those? The conjugate acid base that we talked about in the last video, we mainly use sodium hydroxide. Sodium hydroxide itself is extremely strong, especially when we have a high molar concentration. But it's kind of interesting because once again we can take sodium hydroxide and it actually neutralizes. Sulfuric acid is actually battery acid. Hydrochloric acid is extremely strong. So we want you to begin to realize some of the things that we can use to neutralize. So most common base used to neutralize sulfuric acid and hydrochloric acid is sodium hydroxide. Now, the next thing we're going to talk about, this is an old system for acids and bases. It's called the litmus test. Now, this is pretty old. We'll come over to this side of the board here. And this is kind of an older system where you would have this little tube of red paper and a little tube of blue paper. And it's really the old test. We used to just, I remember back, I graduated from high school in 1979. and I think Moses was in my class. But it was really cool because I've gotten to see a lot of things happen. We didn't have all the acid-base indicators that we have now. We had phenolphthalein, but we didn't have all the different colors that we have. But everybody had this litmus test. And it was okay. It was okay, except you had this little vial of blue paper and a little vial of red paper, and you would dip it in a solution, and if it, once again, if it was an acid, then the blue paper would turn red. And if it was a base, okay, the litmus test for an acid, the blue test strip turns red. The litmus test for a base, the red test strip turns blue. So you would just put it in there. So if it was a blue strip and you put it in there and it stayed blue, okay, so if it was a blue strip and it stayed blue, then you knew it was an acid. I'm sorry, you knew it was a base, okay? If the blue strip doesn't turn red, okay, then it's not an acid. Or it could be neutral. And the red test paper, if you put it in something, okay, and it turned blue, then it was a base. But what's the problem with this? The problem with this is you don't know if it's a strong acid or a strong base. Oh. But every time, but it was a fail-proof test. That's why we say, that's why even somebody will say, that's the litmus test for something. Even outside of science, somebody will say, that's the litmus test for this. If this happens, that happens. And maybe you've heard that saying and maybe you haven't, but I want you to realize it, because you'll probably hear it in your lifetime. Somebody says, what's your litmus test for knowing the right thing to do? Okay, litmus test happens every time. It was fail-proof, okay? So when somebody says, what's your litmus test, that means if you do this, then this happens. Well, that's what happened here. The litmus test for an acid, the blue test strip turned red, and the litmus test for a base, the red test strip turned blue. But we have a real problem in that we don't see the litmus test much anymore because we don't know if it's a strong acid or a weak acid, okay? Even water could be slightly acidic. So if water was slightly acidic or slightly basic, it would turn the litmus paper the other color. So wow. So the litmus test is a good test, but we don't use it anymore. It's almost become archaic. When you're a little kid and you get that, and somebody buys that little chemistry set, or you buy it for your kids, and it says 500 pieces of scientific materials. Well, about 100 of them is a litmus test paper, because even if you put it in your mouth, it doesn't hurt or anything. So I remember getting one of those as a kid. Maybe that's where I did not get my quenchable thirst for blowing stuff up, because that little kit didn't give you anything that was explosive. But what happens is the litmus paper, once again, is a true test, but not a good test, because it doesn't measure the extent of the strength of an acid or a base. So we've got one more video for this test, so I'll see you then.